Welcome back to Moose in Chemistry. Today we're going to talk about oxidation numbers and groups. So on your periodic table you have 18 groups which are shown on the blackboard here. So group 1 will give up 1 electron, giving it a +1 charge. All elements in group 2 can give up 2 electrons. Going over to group 13, those elements will give up 3 electrons. Elements in group 12 will give up 2 electrons, and elements in group 11 will give up 1 electron. Now, group 14 can either gain 4 electrons or lose 4 electrons. 15 can either gain 3 electrons or lose 5 electrons. Group 16 can either gain 2 electrons or lose 6 electrons. Group 17 will either gain 1 electron or lose 7 electrons. And group 18 is noble, so it's not going to give up any kind of electrons. Now, if you give up an electron, you become a positive charge, which is a cation. Cations means that you have more protons than you have electrons. If you gain an electron, you become an anion, which means you have more electrons than you have protons. Now, what about groups 3 through 10? What happens to those? Well, that would depend upon the anion. So those are what we call no man's land. It varies either 1 or 2 electrons, sometimes more. So you have to look at your anion, and then you look at your cation, and that will tell you what your cation charge is going to be. A couple examples of this, like for example, silver chloride. Silver is in group 17, has a -1 charge. That's chlorine. And then silver, of course, also has a +1 charge because it's in group 11. Okay, but what if we had magnesium chloride? So you write MgCl. Now, look over at the magnesium. You notice that's in group 2, so it'll have a +2 charge, and chlorine will have a -1 charge. Well, the charges are not balanced, so you simply will crisscross. You make that MgCl2. And one more example. Let's say we have lithium fluoride. Well, lithium is in the +1 charge because it's in group 1, and fluorine is a -1 charge. So that is balanced, lithium fluoride. Have an awesome day.